Hello, everybody. Welcome to All Space Considered. All Space Considered is the third Thursday of every month, unless it's not, as we'll see there. We'll see if they forward. There it is, except when it's not. As tonight, if we have a special guest or an opportunity for a special speaker, we like to move the show to another night. But tonight is a very special night. And welcome to Griffith Observatory and All Space Considered. And as always, it's brought to you by, of course, Griffith Observatory, the Department of Recreation and Parks, and the City of Los Angeles. And as always, we like to thank our nonprofit partner, Griffith Observatory Foundation. And we thank all the members as well that are out there. This program is coming to you live, of course, from the Leonard Nimoy Event Horizon Theater, and it is being streamed live to YouTube as well. So welcome to the YouTube audience. Tonight, we're lucky to have two very special guests as well as a book signing. I hope the folks here in the audience are ready to pick up some amazing books and get them signed by our speakers. But first, I'm pleased to welcome Griffith Observatory Director E.C. Krupp, who's going to introduce our guest speakers tonight. So welcome to the program, Dr. Krupp.
Thank you, Dr. Reitzel. And we're all about to encounter tonight the warp side of our universe, and are honored that artist Leah Halloran and physicist Dr. Kip Thorne are navigating us through it. As an award-winning artist, Leah Halloran has folded science, nature, and astronomy into her often monumental and always singular work. Many of her pieces are giant cyanotype prints leveraged with celestial themes. Her Deep Sky Companion installation at Caltech's Cahill Center for Astronomy and Astrophysics blankets the primary stairway with all of the nebulae, star clusters, and galaxies that comprise the famous Messier objects. As a theoretical physicist at Caltech, Dr. Kip Thorne has helped domesticate gravity and relativity and cosmology and black holes since 1966. His scientific and cultural credits are numerous and cross-disciplinary. He also has a Nobel Prize awarded to him and physicists Rainer Weiss and Barry Barish in 2017. That's good enough to put him on a postage stamp. He's also the first Nobel Prize winner to speak at Griffith Observatory. Now, yeah, I think. Now, I do want to take a moment to remind everyone that Griffith Observatory is owned and operated by the City of Los Angeles Department of Recreation and Parks, and Griffith Observatory and this evening's program are also, in part, as David mentioned, supported by Griffith Observatory Foundation, the observatory's exclusive nonprofit partner for public astronomy. The foundation is, in fact, a stellar example of a high-performance public-private partnership, and anyone may join the foundation in its mission of supporting the observatory and its programs like this through membership or donation. And I just want to mention, thanks to the Ben B. and Joyce E. Eisenberg Foundation, all donations made before the end of this year will go twice as far through a generous one-time matching commitment. And that sounds relativistic, and it is, like some remarkably felicitous distortion of the space-time philanthropy continuum. And so it makes sense that I mention it here in prelude to Leah Halloran's and Dr. Thorne's presentation. Let me close these remarks by confirming the deep-time character of Dr. Thorne's relationship to Griffith Observatory. In 1973, Griffith Observatory Director Dr. William J. Kaufman III worked directly with Dr. Thorne and Griffith Observatory artist Lois Cohen to create the first accurate depiction of a real black hole, an element of the Cygnus X1 black hole binary. This image was picked up by the media and appeared everywhere worldwide. In fact, here it is on the cover of the November 1974 issue of Sky and Telescope magazine. Let me also document Griffith Observatory's abiding admiration and respect for Dr. Thorne. Here it is demonstrated on the cover of the October 2018 issue of the Griffith Observatory's monthly magazine, the Griffith Observer, with another postage stamp commemorating the LIGO detection of gravity waves and the awarding of the Nobel Prize. Leah Halloran has shared the same lofty pedestal. Her work commanded the cover of the September 2017 Griffith Observer. But what's really in play tonight is the warp side of our universe. Leah and Kip are signing books tonight, and I make this very clear, you need to purchase a book, maybe several, for yourself and as gifts for relatives and friends. The book is massive enough to warp space-time all by itself and gorgeous enough to prompt the accelerating universe to slow down and take a good look at it. But first, Leah Halloran and Dr. Kip Thorne.
Thank you, Dr. Krupp, for that remarkable introduction. It's really a great pleasure to be with you all today to talk about our wonderful collaboration with each other over the last 13 years and the book that it has produced.
First, we're going to start off by doing a reading from our prologue and give you a little bit of an intro to what our book is about.
Our universe is varied and vast. Galaxies, planets, stars, and moons, quasars, pulsars, and magnetars, all made from atoms and molecules just like you and me, and all that we hear and touch and see. Our universe is also endowed with a marvelous shadowy side that is warped, phenomena forged from warped space-time. Witness the ravenous fat black hole that Leah here depicts ingesting her wife, Felicia.
Although this warp side is entwined in the weft of our matter-filled universe, its stars, its planets and nebula, its galaxies and its comets, we humans never saw it until just recently. Why did we never see? Warp space-time cannot produce light or other signals that yesterday's technology was able to perceive. So now, how has that changed?
A very long time ago, 1 billion years in the past, while here on Earth, multi-celled life arose and spread around the globe. But in a galaxy far, far away, two spinning black holes danced round one another, rippling the fabric of space and time. The ripples, we call them gravity waves, sucked energy from the hole's orbit, so the holes spiraled inward, eclipsing each other toward a climactic collision. The holes at half of light speed catastrophically collided and merged. In a brief cataclysmic storm of writhing and twisting space-time that brought the waves to crescendo.
The climaxing gravity waves from this catastrophic collision surged out of their birthing galaxy and into interstellar space. Spreading across our universe for nearly 1 billion years, they stretched and they squeezed all that they met, stars and planets and nebula, in patterns that encoded a portrait of their birth, colliding holes and space-time storm. Then 50,000 years ago, when humans shared Earth with Neanderthals, the spreading and weakening gravity waves sailed into our spiral-armed Milky Way, our galaxy, our home.
On September 14th of 2015, near the Antarctic peninsular tip, the waves flying upward plunged into the Earth, through air and then oceans, then rock. Whispering up through Earth's bowels unscathed and emerging just north of New Orleans, the gravity waves came face to face with a complex and huge L-shaped invention designed and built to perceive them. LIGO, the Laser Interferometer Gravity Wave Observatory. Flowing through LIGO, the gravity waves stretched and then squeezed microscopically two very long beams of bouncing light that extracted the portraits the waves had encoded, colliding holes, and space-time storm.
This tiny shutter in LIGO was momentous for the whole human race, our very first moment of contact with the warp side of our universe. The warp side of our universe is home to many beasts that are forged from warp space and time, beasts that may well include black holes and wormholes, time machines and cosmic strings, gravity waves and singularities, our universe's Big Bang birth, and many other beasts, wondrous, weird, and wild.
For decades, I, a beast, materially composed, have been consumed by quests to fully comprehend this warp side of our universe. How? Through tricks of mathematics and computer simulations, probing Albert Einstein's relativity equations. And in a 1,000-person fleet of scientists and engineers, we've pursued a quest to invent, construct, and utilize our behemoth LIGO for humans' first encounters with the warped side of our universe.
Big questions have driven these warp side quests, some that I'm sure you have asked yourself, and some you likely have not. How did our universe begin? Can anything travel backwards in time? Can advanced civilizations build wormholes for fast interstellar travel? How does warp space-time behave when wildly, frenzied, writhing like the open sea in a storm? How does the warp side of our universe impact the material side, the side that we humans see and feel?
In this artistic, poetic book that will undulate in your hands, Leah and I use paintings and verse to shred some glimmers of light on all of these big questions. But first we shall pause to explore the quintessential example of a beast who inhabits the side that is warped, the black hole. And that is how our book's prologue ends. Now, a black hole has a rich variety of features, all made from warped space-time, likely far richer than you've ever heard of or imagined of. The first chapter of our book introduces those features one by one and then summarizes them in the following way.
What is Felicia? She's the sum of all her parts. Her face, her silken hair, her arms and breasts, her hands and legs and feet, her heart, her brain, her precious personality. And what is a black hole? It's the sum of all its parts. Its space that is warped, the funnel of bulk being seas, its vortices of whirling space, its tendencies that stretch and squeeze, its slowing time and down cascading time, its horizon and its singularities, all made from warped space-time.
All right, we're now going to join David on stage for our discussion. Thank you.
Well, thank you for that introduction. I think my mic is working. I don't think I muted it. Let me double check. I did, of course. Matthew will scold me for that. Well, thank you for that introduction to the book. Fascinating. My first question is, do either of you have a connection in the past to Griffith Observatory? Kip, we heard a little bit about yours with Dr. Krupp, but maybe earlier in life, did you come here perhaps before you were an astrophysicist? Were you inspired by Griffith Observatory in any way?
Well, I grew up in Utah, and I came down to Southern California a couple of times with my parents and family just to see this part of the world. And I do remember coming to Griffith Observatory to the park, and I don't remember details. I just remember the glorious building here and the wonderful countryside around it. And then a little bit later, when I was married and had small children, we used to come up to Griffith to the park to ride horseback on horses. And we'd rent a horse and, rent 4 horses for my wife and me and 2 children. And that was their introduction to the wild, wild west.
Excellent. And Leah, how about you? I think you're a local Southern Californian, if I remember right.
I'm from San Francisco.
Oh.
But I came down here to go to UCLA,
Okay.
and my introduction to Griffith Observatory is probably like many people in the audience, is that I came here on a date. And that's you come for the romance and you stay for the astronomy.
At least that's how we hope it works for it doesn't work that way
but
for
I've been
everybody.
here many times after that.
Exactly.
It's also a good way when you move to LA to actually understand visually how things work.
Yeah. For our YouTube audience, you need to come to Griffith Observatory and see this beautiful view that we're talking about here. Now, you've done artwork, Leah, about science, and Kip, you're doing science with art now. So you both have kind of gone into each other's fields a little bit. Now, how did that happen? You've been doing work related to astronomy for a while now, I know, but how did that start out?
Actually started out with a collaboration with Kip many years before Kip and I met in person. He didn't know that we were collaborating for several years. My mother, who I can see right there, had given me a book as a gift when I was in graduate school at Yale, and it was this amazing book called Einstein's Outrageous Legacy, Time Travel and Time Warps by Kip. Many of you probably have also been inspired by this book. And what I loved about that book is that it gave me the experience of the universe, and it made me think like there was a way to translate what he was thinking about visually. And so in my MFA show at Yale, one of my paintings was based on the writings that Kip was doing. And that was sort of like the beginning of me making work that was actually the subject matter was science.
Now, Kip, when did you first become aware of this?
Well, it's all Leah's fault. She never told me anything about this when she was. she could at least have sent me an email while she was doing this at Yale. She didn't, and so I didn't ever meet her or know anything about this until a mutual friend of ours named Lisa Randall, one of the great theoretical physicists of this generation, was at Caltech on sabbatical, and threw a party for herself when she finished her sabbatical to go back to the East Coast, and invited Leah and invited me.
Okay.
And so that's where we met. Leah came up, introduced herself effusively.
Yes. I think I elbowed a couple people away. I was like, do you want to come over for a studio visit?
And I said, absolutely, I want to come over for a studio visit. I was very curious. I went over, and Leah, I was very impressed by her studio and by the painting she was doing. I mentioned to her that I was just beginning a collaboration with a young filmmaker on a movie, and that I wanted to show this guy what the black holes and wormholes looked like, and could she draw for me a sketch. And so she drew for me a wonderful pencil sketch of a Dr. Seuss-like pencil sketch of the universe with lots of black holes and wormholes. I just fell in love with it and fell in love with her art.
And this young filmmaker was this guy named Steven Spielberg, which probably none of you have heard about. We just don't know what happened to his career, but hoping he's okay.
He dropped out of the movie after a bit. He decided he was going to do Lincoln and not do Interstellar, and so we wound up with that's a Nolan,
small detail he left out. The movie was Interstellar also.
And but anyway, so this was part of the beginning of Interstellar, but it was also the beginning of our collaboration. And shortly thereafter, I received an invitation from a woman, Amy Grace Lloyd, who was a superb editor, who had been my editor for this book that Leah had fallen in love with when she was in graduate school. But she was now working for Playboy magazine. She had been hired to try to make Playboy distinguish itself from other gentlemen's magazines by having higher quality literature in it. And so she wanted me to write an article about the warp side of the universe, of course, because she had edited a book of mine that dealt basically with that. And I said yes, but only if Leah came along and collaborated by doing paintings. She and the art director looked at some of Leah's paintings online, and they thought they were fabulous, and so they said absolutely yes, drew up a contract. We made a wonderful article of about 3,000 words and maybe 5 paintings, and turned it in, and I got an anguished email back from Amy saying, Hugh Hefner says we cannot use this because... But
okay, I got personally rejected by Hugh Hefner. I don't want to drag Kip into it, but basically I had not properly objectified the women in the article. And I thought I was being subversive because I had painted all my queer and trans friends in. I was like, this is going to be the first time they're in Playboy. And he sensed it, and he just... Yeah. I didn't, they didn't meet the traditional... femme.
Well, but this led to great things. When you don't objectify women like that, you end up with wonderful books with the full story.
Yeah.
At least that's what I think.
Yeah, we quickly came to realize that this was a superb opportunity, and we decided we would turn this into a little book. And it was going to be a little thin book, a few pages, and it just sort of grew. And a close friend of Leah's did a layout for the book very early on, and broke some of my prose down into bits that put alongside some of Leah's paintings, and it sort of looked like poetry. And I said, my gosh, this could be poetry, this could be verse, and wouldn't that be interesting to try to make this be not just the standard scientist trying to write prose with an illustrator trying to illustrate what the scientist is trying to write, but if it was tightly integrated verse and paintings. And I mean, this was a real brainstorm for Leah and for me that we would try to do this, and so that's how it came about. From very early in my career, I realized that there was a great deal to be said for watching for unexpected opportunities. And if you see one, think about it seriously and seriously consider it and go for it if it really looks good. This was one of those. I never ever intended to collaborate with a painter. I never ever intended to write verse.
Well, had you ever written any before?
A few love poems to my wife, but that was all. And nothing for the public.
But we actually said for many years that we were just making our dream book, that no one would buy it. It would just be Kip and I.
We would never get a publisher who wanted to publish this thing, but it was so much fun working with each other. Yeah. And we could create something that we could show to our friends and family.
Well, I don't know if our audience quite understands, but in general, scientists aren't heralded as excellent writers. Our scientific articles can be very difficult to get through because they're full of jargon and everything else. So it is quite a leap to take it to poetry. Did you fear that in any way as you tried to do it? You seem so excited about let's make it verse, but we're talking general relativity here. This isn't exactly pretty stars in the sky, the red ones are cooler, the blue ones are hotter. We're talking warped space-time here. So were you fearful at all?
I had the huge advantage over most people that I got a lot more praise for my science than I deserved right from the beginning. So I had my big successes, and so if I do something and it flops, so what? I've had my successes. Let's have fun now. And so it's an issue of having fun, but it was also an issue of trying to use this as a vehicle to inspire people about science, to convey the ethos, the essence of these very fascinating ideas that underlie the warped side of the universe, try to convey them in a powerful sort of a way. And as we got into this, just within a few days or weeks of when I converted over to verse, it became evident, I think, to both of us that this combination of tightly integrated verse and paintings was a new kind of vehicle for communicating science that was not well suited to communicate the details. That's what we do with the usual kind of science writing that I had done a lot of before, but it was very well suited to communicating the essence, to helping people feel, experience this. And it was, Leah really helped me understand that was what we were trying to do, is help people experience the science.
Yeah, I really like the book, the feel of it, the artwork in it, because it has the feel of inspiration to it. Here at Griffith Observatory, that's our main mission. We don't try and teach people the astronomy. We want to inspire people to go out and learn it and connect with the universe. And I feel your book is along that lines. I made it through about a third of it or so already, and I'm excited to read the rest of it, although now that I have the physical copy, I can read in the physical copy. But do you think that the general public, in reading this book, are they going to get a flavor for, I guess, the general relativity and what's going on? What do you hope they get from the book?
Well, let me describe it this way. Mathematics is the language of science, it's the language of nature. And And that is the tool that we use to really understand deeply what's going on in nature and to epitomize it. But mathematics is a very slow vehicle. It's a very cumbersome vehicle when you're working with it. And you have to have something else that gives you inspiration, that gives you huge intuition, enables you to make intuitive leaps and decide what kind of calculations are worth doing. And for me, that's mental pictures. And so I would go to Leah with some mental pictures that are closely tied to my research and say, Leah, can you paint this? And Leah takes off from that. And it may just be a few words, a few sentences. It may be a sketch, but something very crude. And she turns it into something magnificently beautiful that captures what I had intuitively in my mind anyway, but it captures it ever so much better than anything that I had. And so the step from the real science for me to Leah's paintings is just a powerful step, and it's not a huge step, but it's a step that I couldn't do. It's a step that only she can do.
And I would also say that we were very specifically trying to go against the grain of making a book that had any sensibility of being didactic. Like, I love that you're saying you're not trying to teach someone about science here at the observatory, but you're kind of inviting them into this world. And I think that we both have a passion for being very, welcome. This idea is like this book is like a wide invitation that is really a way that you can feel the experience.
Yeah, I think it's successful in that. The reading I did in it made me want to read more and hear more of the story. And it was very much a story, yet it's written in this poetic form. So you're kind of carried into it. It's you move along with the flow is how I think of it.
The paintings carry the verse along, but the verse carries the paintings along as well. And it's a real integrated thing in a way that I didn't realize was possible until we did it.
Yeah. So, Leah, your work, as we saw in Dr. Krupp's introduction, some of them are very large pieces. What's your intention in that? I know you're showing off parts of the universe, but how do you see it all tied together?
I mean, my practice actually spans through many mediums of photography or video installation, painting, cyanotypes, and each one, I actually do exactly what I intend with this book, is actually to try to have the viewer have an experience. And I think you can have that transformation even in a small painting, but in the piece that you saw there, that was like a monument to solar eclipses, and I kind of wanted to make this almost like an altar. Working with Kip, it was in the same way that you pointed out, like him writing in poetic verse. Yes, I'm an artist, but my work ends up in galleries or museums and in the realm of contemporary art, never in illustration or being, making sure that they kind of honor Kip's ideas. And this is very untraditional. We've been working together for 13 years, and it's really just a celebration of our conversations. Kip never came with here's a written verse and now we're going to illustrate it. And so it was really important that all the paintings were very iterative and that I could make them very quickly. So many of them were made with Kip just in my studio. He's nudging it a little bit this way, a little bit that way. So it's, it's nice to work on a small scale.
Now, were there any arguments? I don't want to dig up any.
Someone just asked us this, and we've never had a time that we didn't get on the same page.
I get, because the two of you seem to work so well together.
It's been like a total celebration of
that's
collaboration.
Really fantastic.
We had there's one part of the book that you notice is a little bit different, or maybe one of them will come up on the rotating images behind us, is that the book is done in monochrome blue, and then there's one chapter that introduces another color. And there's a passage that people who know a lot about black holes will be fascinated to know that this is like cutting edge science in our book. It's not just poetic prose, but all this new information about tendencies and vortices, and we needed to find a way to signal opposites of counterclockwise, clockwise, and so
stretch, squeeze. These are dual relationships mathematically that are built deep into the equations of general relativity of Einstein's equations. And this is another aspect we haven't discussed, but I'd say at least half or 60% of the book is stuff we didn't know when we started writing this book scientifically. Wow. That is, the research was going on, and there were great discoveries made, both observationally and in terms of theory, computer simulations. During those 13 years, and the book is a celebration of the 13 years of discovery that went hand in hand with this. And among the discovery was the actual nature of warped space-time in the small, that it consists of things that stretch and squeeze or twist clockwise and twist counterclockwise, the things being space that stretches and squeezes, a space that twists clockwise or twists counterclockwise. And we needed a second color in order to be distinguished.
So Kip said, we need a second color, and I said, absolutely not. And then it was like 2 weeks later. I was like, okay, that's a good way. So that's the closest.
As close as it got.
I mean, even on that note, I mean, it was like right up. Do you remember? It was like a week before it went to final press. There's a painting of colliding neutron stars, and I had made one that I really loved. And Kip said, "There's a new computer simulation. You need to make another one." And I was like, no.
It doesn't look. It doesn't look quite like what you're
And then,
painting.
Of course, I did it, and so right up to the publication date.
Now, did you keep the other one?
It's a really great painting that no one's going to see. I'm just going to give it to you. I told Kip after 13 years, I've made 660 paintings. Just going to come over with a bunch of boxes and put them on his porch.
Yeah, well, that was what I was going to ask. Now, if folks want to see some of this work, they can here in Los Angeles right now.
Yes, you can go to Luis de Jesus Los Angeles, which is in the Arts District, and have a solo show up of the artwork through December 22nd.
Yeah, so be sure to check it out. It's well worth doing to see these paintings in person, although the prints are really lovely. The book is really beautiful. Going back to the science, can we see the evidence of these vortices in the gravity waves? And you call them gravity waves, I notice.
Well, I call it, so they're typically called gravitational waves because the phrase gravity wave is used technically by physicists and engineers to mean the kinds of waves you have on the surface of water, where gravity is pulling the wave down as the ocean wave propagates. That's technically called the gravity. And so that word was already used, but by now gravitational waves have become so exciting. Everybody knows so much about it that we no longer respect those of us who work on this no longer respect that boundary, and we have subsumed the word gravity wave.
Good.
And so,
So I'm on some firm ground if I decide to join.
If you're at an observatory, and you could, I feel like you could
Well,
take it
the
out.
other thing I would emphasize is that my verse is, what's particularly important to me about the verse is what the technical word is meter. I'd use the word cadence, the rhythm. And a gravitational wave has a very different cadence than gravity wave. And so you find both phrases used in the book, depending on the cadence, the meter that is dominating that particular stanza of verse. And so that gave me a little bit more to work with. That I had two different phrases that I could use depending on the cadence that I was after.
Now, back to the question of can we see these vortices? Can we see it with LIGO, or will we have to wait for something like LISA, which is LIGO in space, everybody, which will be the next step to really increase our sensitivity?
Well, so we've already seen vortices of twisting space produced by the Earth's spin.
Yeah.
And that's through something called Gravity Probe B, which was a experiment where NASA flew gyroscopes, superconducting gyroscopes constructed by Francis Everett and his colleagues at Stanford in orbit around the Earth, and they precessed, due to the spin of the Earth, drag space into a spinning motion or twisting motion, fast near the Earth, slower farther away. And that gyroscope experiment showed the existence of this vortices of twisting space sticking out of the north and south pole of the Earth. So we've seen them in that context. I hope I haven't knocked this. Okay. Here, help me. Thank you. In gravitational waves, we see the stretching and squeezing, stretching along one direction, squeezing along the other direction. These are the tendencies in the book. So we've seen vortices attached to the Earth. We've seen stretching and squeezing tendencies of a gravitational wave. We've not seen the vortices in gravitational waves yet because we haven't had good enough technology. Okay. But these things are things that we are seeing in various contexts as physicists and astrophysicists, but things that we were not really aware of until recently, the last 13 years.
Will you be able to tell the difference between black holes with different spins merging? So if one is clockwise, one counterclockwise merging versus two clockwise?
Yes, the waveforms, the oscillations and the stretching and squeezing of the waves that are produced in the black hole mergers are different depending on the spins. So yes, and that's part of in the verse. There's a heavy emphasis on the pictures that are carried by the gravitational waves of the parents of the gravitational waves, the black holes colliding.
Well, this is where we need the artwork to tie it together, though. Yeah. For these gravity waves, we think with sensitive enough detectors, we might be able to probe beyond the cosmic microwave background radiation, which is a wall where visible light and, well, any sort of electromagnetic radiation, you kind of get stuck there. We can't go much past it. But these gravitational waves, they can come from earlier. Do you have any hope in the near future of us detecting anything?
Leah has these wonderful paintings of the gravitational waves produced in the birth of the universe, which we do expect to see. And so the verse and the paintings tell the story of not just of what we have seen, but also the story of what we expect to see over the coming several decades. Mm-hmm. And that's the Holy Grail. And that, so there's a chapter at the very end on the vision of the future that focuses on this Holy Grail of seeing these gravitational waves. There's an aspect, though, I think I'd like to return to before we wind up, mm-hmm. of this book. It goes away from directly from the science, but goes to the essence of how we help the reader and the viewer to understand, to experience the warp side of the universe in a visceral and human way. And that is, and it was Leah's idea to put one human space traveler in the book who appears over and over again, but with this woman, her name is Felicia. She happens to be Leah's wife. She happens to be here somewhere in the audience. But she's a fabulous woman. I'm in love with her. Don't
me too.
But the idea of that you get the human experience through Felicia, experiencing all of the vagaries, the violence, the beauty, experiencing all the violence and the beauty of the warp side of the universe. And she is your surrogate as you read through the book. And I think that is really works really well. And I thank you for bringing Felicia into this.
Well, it was like the way that when we would talk, when Kip would explain things, I would say, like, my head would get hot after our conversations. And the way that I would try to imagine visualizing things is through my body, right? And so many of us understand scale through our bodies, so that when you're looking at numbers as an astronomer, very few people can understand, what so many zeros and so many,
It's a 10 to the 12.
Exactly. And so what we tried to do was to make that human connection. Not only it was an invitation that was non-didactic, it's very specifically trying to have a goal of being intimate. You don't usually think of science in that way. And then also just a connection to your body. And so much of what Kip would tell me, I would try to imagine what these things would feel like, and what he's talking about with gravitational waves and gravitational foam. It was like he would tell me these things, and one of the times I said, well, what does that look like? And Kip said, well, you'll show me when I see that painting. So I think having that human connection is really such a anchor and a focus of our book.
Mm-hmm. Now, were there any artists that inspired you to bring astronomy and science into your work? Obviously, that's what you've done, but did you see any work early on that you thought, that's something I could do? Like, how did that come about?
About thinking about science as a subject matter?
Yeah, because you were reading Kip's book, obviously. That was something in your graduate work, but were you inspired by other artists, or what made you pick up Kip's book to begin with?
I feel like I'm really inspired by artists that have a kind of transformation into that experience or the meaning in whatever the subject matter is. So I'm not necessarily drawn to artists that are specifically making work about science. Ed and I were talking earlier about James Turrell's Road and Crater. I mean, that kind of project or that kind of career is obviously very inspiring and exciting because you don't need to know anything. It's like the experience of looking at the artwork. Even if you don't have any knowledge or know the intent of the artist, it tells you what it needs to tell you just by you standing there.
Yeah. James Turrell is an amazing artist. We were lucky to have him here before, and then also a remote one. So folks, check those out on our YouTube channel if you'd like. So Kip, when did you first decide that you wanted to connect with artwork and sort of expand your work in science and with art?
When I met Leah.
When you met Leah, okay.
I never intended to do that. Well, it's true that I was surrounded by art growing up in the sense that my mother, I grew up in a Mormon family in Utah, and but with parents who were much more worldly than most. And my mother had great paintings going back all the way back as far as the ancient Greeks. A lot of things from the Renaissance, some medieval paintings and contemporary paintings, and she would put them on the bathroom wall and the kitchen wall. And so the bathroom wall and the kitchen wall would be covered with these paintings, and she would change them sort of once a month or so. And so I was surrounded by these, and she would talk to us about them. And so I became familiar with great painters, but it was not something that I ever imagined bringing into my science. Yeah. On the other hand, I did learn very early that the value of of perspective in scientific drawings, and as I said, that my intuition about science is very much built on visual pictures. And so if anybody knows my book, The Science of Interstellar, a number of the drawings in there are hand-drawn by me, hand-drawn with a ruler. But and so I do drawings myself, but they were not artistic drawings, but they're compelling and convey the ideas. But the idea of collaborating with a real artist who does creative art never occurred to me until I met Leah, even though I did have these kinds of artistic connections.
Yeah. Well, your connection to Interstellar in the film and the creative work in the filmmaking, it's a different realm, of course.
But that's also a realm that I never ever imagined I would get involved in. And again, it was because of a chance meeting with somebody. I was set up by Carl Sagan with a blind date with Linda Obst, who was just beginning to produce movies. And so that's
two people no one has ever heard of.
Yeah.
And so it's one of the glories of living in Southern California. If I were living on the East Coast, I'd be meeting senators and representatives and be trying to consult for government. But out here, I meet artists, I meet filmmakers, and I have unexpected opportunities at the interface between science and the arts. And that's what, because of these chance encounters, I've decided to do in the later part of my life.
Well, I think we're very lucky that you've decided to do this, and we have a wonderful book. I think I want to turn to our audience now and open up some questions from the audience here. So, do folks have a question? Yeah, here.
Thank you. Great talk. I'm loving the images. And it's a slightly more technical question. And Dr. Thorne, you are the one person that I feel might be able to answer. I've recently become aware that there's a bit of a controversy over whether a singularity actually exists in the physical universe. Or is that just a word that describes something that we don't know what it is? Or can you?
So, well, there's a recent controversy which is maybe just beginning to hit the newspapers. I don't know whether this is what you're referring to, but Roy Kerr, who discovered the solution of Einstein's equation that describes spinning black holes, has written a recent paper in which he questions whether inside real black holes there are singularities. A singularity is a location where, if you follow the predictions of Einstein's relativity theory, and Einstein's relativity theory, his relativity laws, they ignore quantum mechanics. So you use only classical general relativity with no quantum mechanical fluctuations. The issue is with a singularity is that those Einstein's laws predict, so it is claimed, a singularity inside black holes where the tidal forces, the stretching and squeezing forces, become infinitely big. The twisting forces, the counterclockwise and clockwise twisting forces become infinitely strong. The vortices and tendencies become enormous. And the proof of this, as it existed in the time that Roy Kerr found his solution of the Einstein equations, was only partial. I think, and Roy is pointing out in this paper that he has just put on the web, it's not yet published, that in fact the proof is truly incomplete, and he argues that in fact that this theorem, due to Roger Penrose, who just got the Nobel Prize recently, that the theorem is not predicting black holes inside, singularities inside black holes. Now, what I've just had email exchanges with Dennis Overby at the New York Times, he's the great science writer there, said, hold your horses, don't publish anything on this yet, it's not sorted out, but I'm essentially sure that Kerr is wrong. And the issue is that indeed the partial proof that we had in the 1960s was not adequate to guarantee this, but there has been work since then in the 2000s that completes this, and I think that Roy has ignored that work, and so we have to have it out amongst us in the scientific community. And you've gotten wind of a controversy that I'm trying to suppress in the New York Times until it's sorted out. Okay.
So
can you strike this from the video?
I think we need to invite him here.
These emails with the New York Times were yesterday, so I don't know how you're so current, but.
A quick follow-up: how does this affect your bet with Stephen Hawking? Has that been that's already been resolved?
So the bet is to, let's see, which bet? The naked singularity bet. Yeah, I think
also
that one
another
is
way
resolved.
that Kip's
I think
involved
that one's
with
resolved, but I don't think it
He's trying
affects
to
that
just
bet because
have one story.
I think Roy is missing a piece of the analysis, which is much more recent than the stuff that he cites. But this gives it's probably worth talking about it, just in the sense that this gives you some sense that within the scientific community, these kinds of arguments go on, but we try to resolve them before they reach the New York Times, and we're just in this process right now.
Thank you very much.
Yeah. Other questions in the audience? Yeah, here in the front.
I have two questions, one for the artist, one for the scientist. So first of all, gorgeous paintings, really love them. They look both loose and also very controlled. So I'm wondering how improvisational they are versus if you have underlays, pencil work behind them, because they're just stunning. And for the scientist, Dr. Thorne, really curious about this James Webb Telescope discovery of galaxies that look like they shouldn't exist, because they are, looking so far in the past and seeing fully formed galaxies too close to the Big Bang. Just wondering
That's
what
kind
your
of
thoughts on that is. Sorry.
So I want to repeat the questions for the stream. I didn't do that on the first one, by the way.
Let's do it one at a time.
Yeah, the first question was for Leah. Are your artworks planned out? Do you do like a sketch of them, or are they freeform?
I haven't done any sketches for this book. Every painting was, they're done very quickly, and they look like watercolor, but they're actually an ink that goes on top of a plastic-infused paper. So the paint can't sink into the surface. And so what happens is the paint is just like moving until the water evaporates. So it has a kind of push and pull. It's very difficult to work that way, but it gives this really beautiful kind of out of control kind of sensibility. And so whenever we're working, Kip might have, like you said, it's either words or a conversation or a tiny drawing that he makes, but I've never made any pencil drawings. But the way that I describe it is that I just want the painting to look like it just like arrived fully formed to the surface. But what has happened is that there's so many iterations of that painting. So most of the paintings have a minimum of 3 to 5 and some upwards of like 14, where I make the painting over and over and over. And that sounds kind of strange, but if you think of like an oil painting, I might have a background and then a layer and then a glaze. There's all these paintings that are kind of compressed on there, but I'm doing them over and over and over until what Kip and I are trying to achieve kind of looks like it's even a surprise for me when it comes.
And then Kip's question for you was, do you have any comments, or does your work have any implication on the James Webb Telescope discovery of these galaxies in the very early universe that are very bright? They're surprisingly bright.
Yeah, so my own research does not touch on that. And I have not dug into that sufficiently far to have an independent opinion about it. I would just say that this is a quantitative issue, and I think it's likely going to take a few years to really sort out whether or not there truly is a problem. But I say that talking about an area of astrophysics that I don't work in and that I have not dug into deeply. So that's a gut reaction and not an intellectual reaction. Yeah. It's just that I have seen so many times discrepant results that when dug into much more deeply, the discrepancy gradually goes away. I've also seen discrepant results that I was absolutely sure were nonsense, and they didn't go away. And this is one of the key things about being a scientist, is you get your nose rubbed in your mistakes so often that you become, at least you should, and I think most of us do, become quite humble. I just wish that politicians had that experience.
It's very true. I'll answer a little bit of your question, by the way. There was a recent paper, and I'm forgetting the lead author, which is terrible of me, but there are some results showing that we think there are 2 photon emissions going on in the nebulae, which means you have a star-forming nebula of gas. That gas needs to be very energized, knocking the electrons very high up, and then they do 2 cascade down and release 2 photons when they come down to the ground state. We're seeing that in these nebulae. Now, you can't do that unless you have supermassive stars, and a lot of them. So we think in these early galaxies, there's probably a lot more O-type stars, a lot of supermassive stars that are just making them brighter than we expect. We used what's called the mass-to-light ratio of more like the local universe and interpreted the early universe with it. It was a bad assumption. So that's my take on it, and it seems like these initial papers that are coming out saying, yeah, there's something else going on. But we need to wait and see, because this is just the first paper saying this can solve it, but maybe there's going to be other ways that can do it.
Thank
So,
you for elaborating.
yeah, yeah. Alan, you have a question here.
Thank you. The title of your book, of course, we know that gravitational objects warp space-time, but I've never really heard the phrase "the warp side of the universe." So, is that something you folks came up with yourself, or is this a common term that's used elsewhere?
It's a phrase that I have used for years. It's not a phrase that my colleagues typically use, but it is a phrase which, for me, conveys the idea that that is the essence of much of my career, that there are objects and phenomena in the universe that are made entirely or largely from warped space-time and not from matter, and that there's a great richness to the universe consisting of those kinds of objects. Black holes are the most famous ones. The Big Bang birth of the universe is also a famous example. And so I just use the phrase warp side of the universe to capture that idea that there is this great richness of those kinds of phenomena. I think the issue is that we have not had the tools to study those kinds of phenomena until now. The ideal tool for studying things that are made from warped space-time is radiation that's made from warped space-time, which is what gravitational waves are. And so having been involved with 1,000 colleagues in creating gravitational wave astronomy only less than a decade ago, I see us as beginning to open up our eyes, quote eyes, our observational capabilities to the warp side of the universe in a way that we never had before. So whether this phrase will catch on, I don't know. I don't really care. But for me, it captures in a powerful manner this idea.
I think we have time for maybe a couple of more questions. We'll see here. Way in the back, in the center there.
I have a question for Leah. As you were going through this 13-year relationship, I would imagine you were learning some science through these conversations, and maybe you were having some scientific epiphanies. What was maybe the biggest of those scientific epiphanies that you had?
That's a great question. I mean, I what I didn't kind of talk about is that I have a really kind of open and curious trajectory from childhood. My father is a scientist, so I never felt scared about science or that it was intimidating. It was always something that I felt was mine. And so I always studied science. I felt like it was like a way, and I think as an artist, you're interpreting the natural world. So by the time that I met Kip, I had been taking a lot of astronomy and physics classes, and I think what gave me a foundation level of the understanding, but basically the biggest kind of epiphany was exactly what was happening with Kip. Like, we had created our book to a certain point, and I remember saying, okay, do you think, like, where do you think we're at? And I think this was in December, and you said, I think we should wait a month. And basically he knew that LIGO had discovered, I just can't believe you're going to tell me. We're going to talk about that after the lecture. But that, basically, like Kip was saying, our book changed so drastically as the new discoveries are happening, LIGO discovering colliding black holes, and the changes that the computer simulations are having. So I like to think that even if we continued our, meeting every 2 weeks and making these paintings over these years, like, we could have a different book in 5 years from now that would just kind of show us exactly where we're at that point in time. So I feel like I'm on the adventure as well as Kip, as everyone else.
Yeah. So one last quick question in the front here.
Yeah.
Hi, it's for Leah. Do you see yourself, because you're painting things about the universe, do you see yourself doing anything like in the microverse, maybe like microbiology, like single cell organisms? Do you see yourself? I would love to see your artwork if you did something like that. Obviously not the painting would be microscopic, but like drawing, I don't know, tardigrades or drawing single-cell organism.
Yeah. I love the idea of scale. I think that it is such a fascinating combination and collision point for artists and scientists. So it's a way that we can, artists have to contend with scale, so do scientists. So for Pacific Standard Time, I'm making a piece for the Getty that is actually based on scale. And it will be a very large piece, but it will actually explore these realms of scale. My work this is probably the most closely fixed to certain ideas or concepts, but much of my work actually does explore kind of different realms of scale. I've made works that were based on crystals or light or things that have or geographic location that don't necessarily always happen to have a really, really large astronomical scale.
Yeah. Well, we've reached the end of our program, so let's thank our guests one more time. Thank you so much.
Thank you so much.
Yeah. Now, as always, I want to thank Griffith Observatory Foundation, our nonprofit partner, for all their support. Tonight's program was brought to you by Griffith Observatory, the City of Los Angeles, the Department of Recreation and Parks. And as always, All Space Considered, we'll see you again next month, everybody. And all of you that are here in the audience, go get yourselves a book, get in line to get it signed, and we're going to get our speakers out to the book signing. So thank you all for joining us. Thank you.